Okay, so part of the reason we went through and learned about those removable discontinuities, horizontal asymptotes, and vertical asymptotes is we use them to help us draw a sketch of graphs that we don't really know what they look like. So if we look at the equation they give us for this model problem, I look at this and I'm like, I have no idea what that looks like. So what we do is we're going to follow this process, and at the end we're going to draw a sketch of our graph. So first thing is you always want to write this in that factored form. So when we're factoring this, I'm just going to do this over here. For the top here, we have that 3x squared plus 4x plus 1. So I'm saying, okay, well, what multiplies to 3 but adds to 4? And it needs to be positive. So I'm going to do a 3 and 1 here. With this one, because of that 3 being out in the front, we have to use our box method. We're factoring by grouping, whichever you prefer, and you're saying, hey, what multiplies to a 3x squared? And then we're going to use the 3 and 1 to fill in the other box. 3x, x, and then we fill in that 1 at the end. So if I'm looking here, I'm saying, okay, well, I'm going to take an x out of each of those. Here, I can take a 1 out of each of those. They have nothing in common. Here, they both have a 3x. And here, the same thing, they only have a 1 in common. So far for my function, if I write that down here, g of x, on the top we're going to have an x plus 1 times a 3x plus 1. Now I need to go through and factor out my denominator. So for that one, we're saying, okay, well, what multiplies to 3 but adds to 4? So same thing again, 3 and 1. So we're going to end up with x plus 1 and an x plus 3. So next thing is saying, hey, identify the location of any removable discontinuity. So remember, that's when we have that common factor on the top and the bottom. So I look up here and I say, hey, if there's an x plus 1 and an x plus 1, these each cancel out technically. Reasoning for our removable discontinuities. But then we also need to find if there's any vertical or horizontal asymptotes. So first thing, let's just look at that removable discontinuity. So we're going to say, okay, well, we're taking that x plus 1 equals 0, so that means we have x equals negative 1. So our removable discontinuity is at x equals negative 1. Now, for the vertical asymptotes, we say, okay, well, what was left in our denominator? X plus 3. So we take x plus 3, set it equal to 0. So x equals negative 3. Well, that's going to be our vertical asymptote. Now, for horizontal asymptotes, remember, we want to look at that end behavior. So what I'm going to do actually is I'm going to rewrite this so I have that 3x plus 1 on top and x plus 3 on the bottom because it's easier to plug into, and I get rid of that discontinuity. So horizontal asymptote is saying, hey, what happens to that end behavior? Where is this going to be? But I have an x over x here. My m and n are the same. You can see that up here as well. They're both x squareds. So what we can do is say, okay, well, that's going to be at y is equal to whatever our front values are, 3 and 1. So 3 over 1 or 3. So that's going to be our horizontal asymptote for this. Now, another helpful part for this is finding those x and y intercepts. So to find x and y intercepts here, I'm just going to say, okay, well, x-intercepts, that's when my x is equal to 0. So if I find g of 0 here, that's going to get rid of anything that had an x in it. So if I look up here, those are going to go away. It's just going to be a 1/3. So that means I know the point 0, 1/3. Now for my y-intercepts, I say, hey, this is going to give me a y equals 0. So that means we're going to have a 0 is equal to my function 3x plus 1 divided by x plus 3. But if this is going to be equal to 0, it doesn't matter what my denominator is, it just matters if my numerator is 0. So really what I can do is I can rewrite this as 0 is equal to a 3x plus 1. So then I can say, okay, well, negative 1 equals a 3x. Last part is to divide. So x is going to be equal to a negative 1/3. That tells me the point negative 1/3, 0. So down below, I'm going to go ahead and plot these points that I know so far. So what we have is we know the point negative 1/3, 0. We know a 1/3, or sorry, a 0, 1/3. So we know these 2 points here. Now we also know some of our asymptotes. We know our vertical and horizontal. So x equals -3, that's going to be our vertical. Horizontal will be up here. So look something like so. Drop both of these in. I also know that removable discontinuity occurs at x equals -1. I can find that y value if I plug it into my equation after I've canceled. So g of -1 is going to be equal to a -3 plus 1 divided by a -1 plus 3. So let's say -2/2 or a -1. So that means my removable discontinuity is at the point -1, -1. So at that point, I'm going to draw in a big hole there. So we have our horizontal, we have our vertical, but we still need a few other points because it's saying, hey, you need to sketch a detailed graph of the function using a minimum of 6 points or key pieces of information on the graph. Well, we have 3 points and 2 asymptotes. And these 3 points over here give me a pretty good idea that, okay, my graph's going up and it's going to approach that asymptote. It's going to come down, approach that asymptote. That's my graph here. I need another point to tell me what's happening over on this side of my graph. So what I'm going to do is I'm going to just plug in -6. Because -6 is here. It's going to tell me what's happening on this quadrant. Is it going to be going down here? Is it up here? What's happening? So if I plug in g of -6, I end up with a -18 plus 1 divided by a -6 plus 3, which is a -17 over -3, which is approximately like 6. It's a little less than 6. It's going to be about 5 2/3. So I'm going to go over to -6 up to 5 2/3. That's my point. It's up here. I only really need that one point to get an idea of the shape of my graph. Because I know it's going to come down and approach this asymptote, because that's part of our definition of an asymptote. And it's going to go over and it's going to approach this one and continue up. So that is our detailed sketch of our graph. We'll do another portion on this in the next video, but this is it for that first part.